Welcome everyone to my YouTube channel. In today's video, we will learn about parallel processing in psychology. In cognitive psychology, parallel processing refers to the ability to deal with multiple stimuli simultaneously. One example is driving. When driving a car, we don't focus on driving exclusively, we also listen to music, carry on a conversation with passengers, and look for the street where our destination is located. Our ability to process different kinds of stimuli at once enables our brain to carry out all these tasks at once. This article discusses the discovery of parallel processing, how it works, and the limitations of this brain function. Origins of parallel processing theory. The idea of parallel processing originated in the mid-20th century, around the same time as the more general concept of information processing theory. It was joined by the invention of computers in the mid-20th century, when psychologists liken computer processing to the way the human mind works. This led to the ascendance of cognitive psychology. How parallel processing works. In parallel processing, we take in multiple forms of information simultaneously. This is especially important in vision. For example, when you see a bus coming toward you, you see its color, shape, depth, and motion all at once. Assessing those things one at a time would take far too long, but seeing them together, you can quickly determine what you're seeing and decide how to respond. In this instance, parallel processing helps you recognize that you must move before the bus gets too close. We engage in this process constantly, even though we're not conscious of it. Parallel processing also relies on a combination of top-down and bottom-up processing. Top-down processing involves using your experiences, expectations, and knowledge to make sense of your perceptions. If you were to see an animal running toward you, top-down processing would help you interpret whether you're seeing your dog running to greet you or another animal running to attack you. Bottom-up processing doesn't rely on existing knowledge to assess information. Instead, our senses take in the most basic aspects of a stimulus, which the brain uses to form a complete picture of the information. Although top-down and bottom-up processing seem incompatible, parallel processing relies on both at the same time to help you understand stimuli. Say you see a person jump off a pier and then you hear splashing. Bottom-up processing uses your senses to build a picture of the incoming data. In contrast, top-down processing of sight and sound would tells us that a person simply jumped into a body of water. Thus, with parallel processing, we can efficiently process and understand the whole of all the stimuli we take in. Automaticity, the brain's autopilot. If you practice an action repeatedly, you eventually become so skilled at the task that you can perform it with little or no thought. For example, someone who types on a daily basis soon becomes so proficient at it that they use only minimal brain resources to do so. This is called automaticity. Automaticity is the ability to act without conscious thought, which happens when a behavior becomes overlearned. There are degrees of automaticity. For example, experienced drivers can follow navigation directions and perform other tasks from behind the wheel more easily than less experienced drivers. Automaticity enables people to perform impressive feats of parallel processing. For instance, in one study, students practiced reading for comprehension while writing down dictated words that they categorized for meaning. The participants learned to perform these tasks without difficulty over several weeks of practice. That's because writing down the dictated words became automatic and no longer drew participants' attention away from what they were reading. Limits to parallel processing. Psychologists have long tried to determine how much information people can process in parallel. So far, they've arrived at different answers. But the general takeaway is that we can process only so much information simultaneously before we must deploy other strategies, such as processing information serially. This may be less efficient. Serial processing. This theory proposes that we process information in the order received. It first enters short-term memory, where it resides until another bit of information bumps the first into long-term memory. Parallel processing is also limited by what psychologists call serial bottlenecks in information processing. As a general rule, we only pay attention to the most salient information in our environment because if we paid attention to every single piece of information, we'd be overwhelmed. However, without practice or great concentration, we can typically use a single cognitive system to process more than one piece of information at the same time. For example, think about how difficult it is to rub your belly and pat your head simultaneously. A single cognitive motor system controls our hands. This makes it challenging to give processes that work in opposition to one another, like rubbing one part of your body and patting another, equal attention, and as a result, do them equally well. Summary: the fascinating study of information processing proposes a few different theories for how the brain encodes, stores, and retrieves memories. Automaticity: when your brain learns a task so well that it doesn't require focused attention to perform it, can help free up cognitive resources that we can then apply to these tasks. Goodbye and see you in the next videos. I'm Mr. Cognitive Quest.